Okay, so I have your Unit 13 test pulled up. First question says, to find the common ratio of the sequence. So when you're finding a common ratio, you're trying to figure out what are you multiplying each term by to get the next term. And if you look at the first one, you can definitely see it's a decrease. So it's how to get from negative 172 to negative 86. So if you simply divide those two numbers in your calculator, negative 172 divided by negative 86, you get 2. So you're not multiplying by 2, you're dividing by 2 to get from one to the other, and dividing by 2 is the same as multiplying by a half. So it's basically a half from one term to the next. Okay, number 4 asks about exponential growth. So it says a scientist counts 35 bacteria present in a culture and finds that the number of bacteria triples each hour. The function y equals 35 times 3 to the x models the number of bacteria after x hours. Estimate when there will be 550 bacteria in the culture. So this is your initial and this is your ending. So end and initial, and this will always be that will always be true in this formula. So we're going to put 550. We want to know when there will be 550. So that's 35 times 3 to the x. We're actually solving this equation for x. So we start by dividing both sides by 35 to, we're trying to get that exponent by itself. So 550 divided by 35 is this really funky decimal, 15.71428 blah blah blah, 3 to the x. Now we've got to get the variable by itself. So what we need to do here is take the log of both sides, or the ln of both sides, so if you take the ln, and I hope that this is how they kind of taught it in the notes. If you take the ln of both sides, this is just a function on your calculator. There's a button that should say ln. If you take the ln of 3 to the x, you actually get x times the ln of 3. You can rewrite it like this. So on this side we still have the ln of 15.71428. And now to solve for x, we're going to divide both sides by the ln of 3, because that's going to cancel. The ln of 3 is just a number. So in your calculator, you should have an ln button. You'll type the ln of 15.71428, and because we've rounded, I've got enough digits there that it should work, and you're going to divide it by, and you can hit enter there if you want, then divide it by the ln of 3, and you should get 2.5073. So this is hours. It's about 2.5 hours, or that first answer choice there. In the next example, again, we're finding a common ratio. So how do we get from the first number to the second number, the second to the third, and the third to the fourth? So from negative 4 to 8, negative 4 basically times what gives you 8. So you divide both sides by negative 4. X equals negative 2. And you see that if you continue to multiply by negative 2, 8 times negative 2 is negative 16. Negative 16 times negative 2 is positive 32, and so on. Okay, so here we have another exponential growth. It says, suppose the population of a town is 2,700 people, is growing 4% each year. Write an equation to model the population growth and then predict it after 12 years. So it's always the initial amount first. So y is going to equal the initial, which is 2,700, times and here's where we need to have basically the amount that it's growing by every year. And so if it's 4% every year, that would be 0.04. But what you have to take into account is that there's also an initial population that we started with. So we take that into the account, and you'll see here in the correct answer how it's 1.04. So it's really 100% of the population plus the additional 4% that it grows every year. So that's how we get 1.04, and then our x here is time. So that's why that second equation is correct. So again, it grows by 4% every year, but you also have to take into account that there were people there to start with, the 100% or the 1, if we change 100% to a decimal. So the 1.04. Now if you plug a 12 in, because it asks after 12 years, so this is in your calculator, you would do 1.04. You can use that little caret in your calculator if you don't, 1.04, and then you push the caret button to the 12th power, and then you multiply that by 2700, and you get 4,323 if you round up. Okay, so 11, drop a ball from a height of 1.5 meters. Curved path has 74% of the height of the previous path. Write a rule for the sequence. The initial height is given by the term n equals 1. And what height will a ball be at the top, of the sixth path? So again, we want our initial to be the 1.5 meters. Notice though it does ask you to, it does ask you to change to centimeters. So because we're changing to centimeters, we're going to move this 2 decimal places to the right. So that's 150 centimeters. And then it's 74% of the height. So we change that to a decimal. And we're doing it to the x minus 1 term. So you can see that that is equation, the third one here, and it looks like on yours you just forgot that because it went from meters to centimeters, you do need to change, move your decimal and change that. So then if you plug in 6 for x, you should get this answer 33.29 centimeters. Common ratio on 12, it looks like we're dividing again by 2. Dividing by 2 is the same as multiplying by a half. Okay, so the first, fourth, and eighth terms of the sequence, that means you're plugging in a 1, a 4, and an 8. So you would have negative 5, whoops, why is that happening? You would have negative 5 times 3 to the 1 minus 1, that's the first term, negative 5 times 3 to the 4 minus 1, that's the fourth term, and then negative 5 times 3 to the 8 minus 1 would be the 8th term. So now we're just plugging this into our calculator. 1 minus 1 is 0. Anything to the 0 power is 1. So this is negative 5 times 1, which is negative 5. 4 minus 1 is 3. 3 to the 3rd power is 27. So it's negative 5 times 27, which is negative 135. And then negative 5 times, I have no idea what 3 to the 7th power is, so in your calculator you can do 3 times 3 7 times. It's 2,187, and when you multiply that times the negative 5, you get the 10,935. So again, another population question. So our initial population, 250 crickets. It's doubling in size every 3 months. So how many crickets will there be after 2 years? And it is doubling, so that's what we have as our base. But because it doubles every 3 months and it wants to know after 2 years, you have to find out how many times does 3 months go into 2 years. So in 2 years there would be 8 3-month chunks. So this is an 8. So in a year it would double 4 different times because 4 times 3 is 12. So in 2 years it would double 8 different times. So 2 to the 8th power is 256. So 250 times 256 is 64,000 crickets. That's a lot of crickets. Okay, so I think that's it for the test. I will reset it for you, and you can watch this video and hopefully that will help you through it. And it looks like this is your last unit, so then you would have until Friday to take your unit test and let me know, or excuse me, your semester, like the final. So let me know if you have any questions.